Hello everyone, welcome to our data interpretation video series. In this video, we're going to talk about multiple graphs as part of the data interpretation series. This series is brought to you by Learning Made Easy team, a team of IIM grads in association with our e-learning partner GTCUBE Get to the Top. If you're watching this video in the YouTube channel, do check out our full-length courses available for free at gtcube.com/store, where you'll get to watch these videos as part of the course and also get to practice lot many questions that will help you understand the concepts better. So let's get started. So if you have been following this series, we have talked about a story of a town with two shops, a piece of information being given about their sales. Shop A sold 300, 250, 400 in last 5 years, 2015 to 2019. Similarly for shop B also, the number of units being sold over the same 5 years has been given. We convert this piece of information into tabular form like this. So using this piece of information, let's go ahead. So what is this that we are talking in this video? We are talking about multiple graphs. So we will see some questions where we'll have more than one graph or one sort of data presentation to give you more information. It could be a combination of a pie chart and a table, or a bar graph and a line graph. It could be anything, or maybe bar graph and bar graph as well. Doesn't matter, it could be three graphs, whatever it is. So you have some piece of information, we are trying to give you more information in multiple graphs, etc. The problem in these questions, right, fundamentally what you'll see is the basic data representation stuff only, like the bar graphs, the pie charts, the line graphs, etc., what we have already discussed in the earlier videos. But the important concept that you need to understand or build in this for this set of questions is, how can I link the graphs that are being given? Like if I give you bar graph and line graph, what is the relation between the information that I see in both? Sometimes there could be no relationship, they are two individual pieces of information. Sometimes there will be a relationship connecting couple of elements in bar graph, the graph 1 and graph 2, which you have to really understand. Students get confused or they sort of miss the point or the logic. So when you see the piece of information, before you deep dive into the question, sort of try to understand both the graphs and see if they're two independent graphs or if they have anything in common and anything like connecting point, and what is that. Once you understand that, it's easy to solve the questions. Let's look at the same piece of information, right? Just to make it how the information could be given, I'm just trying to convert this into two different graphs, like graph 1 and graph 2. What is this graph 1? It's talking about, it's showing a pie chart showing the percentage of sales over the 5 years for the entire town, which is basically shop A plus shop B. All the while we have not talked about this. Let's assume there are only two shops. So in 2015, shop A sold 300, shop B sold 250. So that is, the town as a whole has seen a sales of 550, 600, 350, 500, etc. Right? Let's assume I don't know this. Let's assume I don't know this. I only know the shop A units. That is the graph 2 talking about. Right? In 2015, shop A sold 300 units. 2016, shop B sold 250 units. Right? So on is given in the graph 2. From this graph alone, can I comment on the shop B? No. Hence, I cannot even comment on the entire town as well. But they have also given for the graph 1, which is the pie chart, which is in percentages. 22, 22, 24, 14 and 20 percentage. That's the total sales, a percentage wise for each of the year. If you just see this, as we have already discussed in the pie chart, with the percentages alone, I cannot comment the actual sales. If you ask me in 2016, how many units were sold in town? No idea. The answer is cannot be determined. I cannot give you a certain answer. I just know that the total sales, whatever the total sales be out of adding all 5 years in the entire town, I should be, making 22% of the total sales in the year 2016. That is what this 22% is. I don't know what is the total sales, hence I cannot give you the actual sales in 2016. For that reason, you'll also have a clue like this. The total number of units sold in the town is 2550. Now I know that the entire unit sold in the town is 2550 over the 5 years. So how many units did the town sell in 2016? That is 22% of 2550. So that is 22 by 100 into 2550. Right, 5 2s are 551s are 2 11s are. So what am I getting? 11 1s are 11, 11 5s are 55 plus 1 561. Right, this is what I'm getting. So if you see it's 550 in 2016, this one is because these percentages are approximated. Technically you should be seeing 21 point something in decimals, but the graph is basically approximated. If I add up, you see 22 plus 22 plus 24 is 68 plus 14 is 82 plus 20 is 102. The whole thing is coming as 102%, right? That's because the values are approximated while this graph was constructed. You won't see that happening in the actual question, so don't worry. I'm just showing you, but that is how you do it. Once I do the individual percentages, I know in 2016, let's say in 2016 561 units were sold in the town. How many units of Shop A were sold? 250. This is something I'm reading from graph 2. From the graph 1, I read that the 560 is the total number of units sold in 2016 in the town. Right, Shop A in 2016 sold 250. So how many did Shop B sell in 2016? To 561 minus 251, that is 311, something like this, right? The actual answer should have been 550, so minus 50 300. That is what this is, but I'm just, have done slight approximation, so it's okay. The point is this, that is the logic of connecting the graph 1 and graph 2, right? The graph 1 and the total number of units sold is going to give me the town wise sales, that is this piece of information, and the graph 2 is talking about this piece of information. If the question is asking me how many units were sold by Shop B in 2016, I should subtract this minus this to get this. That is the relation between the graph 1 and graph 2. Be clear with that, right? That's what I'm saying. You should understand what piece of information is given in both the graphs and how they have some connection in between them. That is the complexity, or that is the key point in multiple graphs. So let's get to some problems. So this is a set of questions where we see two graphs. One is a bar graph and one is a table. So this first graph is basically, the title is number of employees working in various departments of an organization and the ratio of men to women in the same. So this one, the ratio of women and men to, that's like this part. So the title of this graph should be the number of employees working in various departments of an organization. In a company, production sees 15%, 26% in IT, marketing 22%, merchandising 18%, 11% in HR and accounts 8%. Again, as I said, do I know anything about, if I ask you from this piece of information alone, how many employees are working in production? No idea. I only know that out of all 15% of them in production. But I don't know the individual values. But this piece of information, you see the total number of employees, that I can use to figure out. So if I ask you how many people are working in production, that is 15% of 4,600. This will be 15 by 100 into 4600. So 00 get cancelled. 15 6 are 90, 15 4 are 60, 690. So 690 people out of 4,600 are from production. Similarly, I can find for the others. Right? Once I know them, what is the second table talking? This is talking about the ratio of men to women in each department. In HR, the ratio of men to women is 1:1. In accounts, the ratio is 3:1. If I ask you how many women are working in production, right? I know the ratio is 3:2. I know the total is 690. How did I get this? I got this from this table, this graph. How did I get the men is to women ratio? That is from this table. Then it is asking me to find how many women. It will be 2 by 5, 2 by 3 plus 2, 2/5 of 690 will be giving me the number of women in the production team. That's how these two tables are, these two graphs are connected. So let's get to the problems. What is the number of women in the accounts department? Similar to what we have done here. So accounts department, this 8%. So what is the number of people? 8% of 4,600. So that is 8 by 100 into 4600. 8 6 are 48, 8 4 are 32, 368. That's the total number of people in accounts. What is the ratio of men to women in accounts? 3:1. So for every one woman, we have 3 men. Right? So that is men is to women is 3:1. So actual numbers, I take it as 3K, 1K, So the total is 3k plus 1k. Total I have 4k people, men plus women. That should be equal to 368. That is 4 9s are 4 2s are. So that means k value is 92. So 3 into 92. Men is 3k, right? That is 3 into 92 is 276. The women is 1k, so that is 92. So 368 is the number of people in the accounts, out of which 276 are men and 92 are women. So the answer is 92 women. What is the total number of employees working in the IT department and HR department together? For this, I only need the first graph. It is talking about the overall number, not with respect to the gender. IT department, what is the percentage? 26%. HR, 11%. This is 26% of 4600. This is 11% of 4600. So I can actually add both. It is because of the same value. So 26 plus 11 is 37% of 4600. Now this should come to you intuitively faster. So 37 by 100 into 4600. So I just need to do 37 into 46. What I'll say is I'll mark this option straightforward. Why? Because 37 into 46 should end with 7 6 are 42. None of the options are ending with 2 other than this. But let me multiply and show you what I'm talking about. 6 7s are 42, 6 3s are 18 plus 4 22, 4 7s are 28, 4 3s are 12 plus 2 4. That should be 2 0 7 1 7. I think somewhere I did a mistake. Let me do 6 7s are 42, 6 3s are 18 plus 4 22, 4 7s are 28, 4 3s are 12 plus 2 is 14. So that's correct, right? So 2, then I have 10. So it should have been 1702. I think the option is wrong. So it should be 1702. But anyways, as I said, this would also help you once you sort of figure out the last digit. Is it there anywhere else? So the answer is 37% of 4600, and that's how you find the answer to be 1702. The number of women in the merchandising department forms what percentage of the total number of employees in the organization? What is the total number of employees? So this is basically this. The number of women in the merchandising department forms is like equals to here. What percentage of the total number of employees in the organization? The total number of employees in the organization is 4600. I need to answer the number of women in the merchandising department. For that, I need to understand in merchandising department what is this 18%. 18% of 4600 is the total people, right? So let me not do this. Okay, I'll show you. Let me calculate it first. I'll show you what is easier way for this. 18 by 100 into 4600 is 18 into 46. So 18 6 are 108, and then 18 4 are 72, 82. So it is 8, right? 108. So 828 is the answer. 828 is the number of people working in the merchandising department. Out of which, what is the women? Merchandising, it's 5:1. So it's 5k. This is 1k. The total is 6k. 6k is equals to 828. So 6 1s are 6. 6 3s are 18. 6 8s are. So k is 138. So I have 138 women. So 138 is equals to x percentage of 4600. So x by 100 into 4600. So this gets cancelled out. 138 is equals to this. 46 3s is 1. So that's basically 3% is the answer. So what I was talking about earlier, see, once I know this is 18%, right? Let me not find out all of this. I just know this is 18% of 4600. That's the total number of people merchandising. What is the fraction of women? If you are comfortable with the ratios, you understand this should be 5:1. That means the woman is basically 1 by 5 plus 1. That's 1 by 6th part of the total. So 1 by 6th of 18% of 4600 is equals to the x percentage of 4600. Of 4600 is into 4600, right? So simply I cancelled this. So x percentage is equals to 1 by 6 into 18%, that is 3%. So x percentage is 3%. Answer is 3. You can actually save time if you just take this as it is rather than calculating them individually. But as I said, this is the fastest way, but it's okay if you take a minute more, but you get it right. Don't do it in this way and get a wrong answer, right? It's okay to push yourself while you learn. It's okay to make a mistake as long as you understand them better. But if you're not understanding them, don't worry, stick to a normal way and you'll still get the answer. What is the ratio of number of men in the production department to the number of men in the marketing department? What is the number of men in the production department? So it's basically the ratio of this 2 is number of men, right? So I need to find this by this. So what is the number of men in the production department? What is the number of people in production department? Production is 15% of 4,600. What is the fraction? Number of men in production. Production is 3 men, 2 women. So that's basically 3:2. So the ratio will be 3/5. 3/3 plus 2. So 3/5 into this is the number of men in production department. Similarly for marketing department, 22% into 4,600 into marketing department 1:1. So that's basically 1/1 plus 1. Half of them will be men. So it's half. Cancelled. 5 3s are to 11s are. So I'm basically getting 3 3s are 9/11. So percentage is also by 100. They also get cancelled out. It will finally come out to be 9/11. This will be the fastest way to do. I just try to show this by not calculating more. Otherwise the way to do is this: 15% of 4,600. I find that I get a value for this. Once I know it, I know that it is 3:2 ratio, right? And then I do 3k 2k and find the k value, and then find the men is 3k. So I find the men. Similarly do it for the marketing department as well. Marketing is 22% of 4,600, and then do all of this. It still give you the same answer. It just will take you more time, right? As I said, the complexity or the key point in multiple graphs is identifying the relation between both piece of information, graph 1, graph 2. Sometimes there will be a good relationship between both of them, and that would make it complex. Sometimes there will be no relationship between them. All you need to do is read them individually, independently, and solve the questions, right? So thank you for watching this video. If you're watching this video in the YouTube channel, do check out our full-length courses available for free at gtcube.com/store, where you'll get to watch these courses part of the course. You'll get to watch the videos as part of the course, and also get to practice many questions that will help you understand the concepts better. Do like our partners Facebook page, facebook.com/gtcube3. We're coming up with a lot of content for various exams. You'll get all those updates shared over there, so don't miss them. Thank you for watching this video, and let's meet in the next video.